I'm going to treat this more like a Olympic relay race. So I'd like to quote a couple of things that Benedetta said that I thought was awesome and almost exactly what I am planning to talk about here. One, she referred to a part of a project as being an artificial naturality, this one piece, and referred to the emergence of another kind of nature. Yeah. See, I was listening very closely. And there was another thing about people can't read the calligraphy, but the elements can. I thought that was fascinating. So it's almost designed for a different kind of audience, not for human beings, but something much bigger. And the pavilion becoming like an animal. I thought that was also fascinating. So I would like to address all of these things, and I am going to organize my talk around these two photographs that have had a very important role as markers and kind of shifts in our thinking in our office. Last time I was at this podium at the school, it was more of a lecture of our work, and I was kind of afraid of repeating too much, the same lecture again. So it's kind of formatted a little bit differently, and it's probably appropriate because I would like to directly address the theme of the conference, which is really too good to pass up. Technology at the intersection of nature, culture, and meaning. And I think that is a really, really interesting topic and also very much central to what we've been going through in our office too. So we're kind of at a crossroads in our practice. We're kind of at the kind of fulcrum point between young practice and I guess mid-career practice. If these are very artificial distinctions, of course. But for the past 2 years, most of my work has been in writing a book. And so that's ending this summer. And so this is kind of a good moment, kind of like a midterm review, I guess, of the kind of ideas that we've been developing. And the reason why I did try and force a pause in our practice, and it's been very difficult to try and maintain that pause. The world just keeps bombarding you and have to say no in order to do that. But we thought it was necessary because we didn't really want to proceed after our initial period of work without consolidating what we had learned and to also concretize it in terms of a proposition about architecture that could then sustain us for hopefully a long time. So this is just a photograph of our office, and I wanted to show you this because I tell my students, please don't use me as your role model because I don't think how we did it really makes much sense. It was very much part of the milieu we were in a kind of I guess, early days of digital architecture, and we were in odd situations, like we knew how to use the computer while we were in school, and our teachers didn't, and then you graduate, and then all of a sudden everybody wants to hire you because you own a computer, and it's bizarre, you know, and I think it was kind of part of the madness of the kind of Wild West days of the computer. But we're most definitely, I think, on to another period in the digital. And it's kind of a colloquialism. Every year I find it more and more difficult to understand what that is actually referring to, and which is also a reason why, for me, it seemed to necessitate a pause to think somewhat more philosophically about just the history of the computer, how we think about the digital and what that means to us, and finally, what does all of this say about the discipline moving forward? So I've never shown this slide before in one of my lectures, and I wanted to do so because I wanted to admit that this is something that really bothered me ever since I first saw it. It seemed to be such a bogus account for where architecture originates from. And I also had trouble accepting it because as somebody who was studying philosophy before getting into architecture, the roots in Rousseau, for example, were just too obvious, even though that was seldom discussed when Logère was discussed. And so I couldn't help but see this as a very artificially constructed notion of nature, and therefore an artificially constructed notion of the origins of architecture. So the question probably is more, if you put importance in this, what are you trying to say about the way architecture should be? And the root of the problem really, what everything always seemed to come back to was this word nature. And nature itself is really weird. It's actually not beautiful conditions and forests and gardens. You also have to think about bizarre things like this. I try to find the weirdest things in nature for this talk. This is how slime mold reproduces. It actually bursts through the surface and produces, and it's fascinating where it locates, where the fruit emerge. But for lack of a better word, it is fruit, and then they pop and disperse spores. Very strange, almost a non-organic form of life. It is absolutely bizarre. Here's another strange object from nature. This is the blood belly jellyfish. And it is a self-luminescent organism. And again, I mean, how do you judge something like this according to the frameworks of nature that we historically operate from, in the sense of Logère and our general kind of oppositional relationship to nature as architects? So this is closer to what we think of when we say nature. And if you maybe perhaps zoom in on one part of this, you might find something strange, like a scene like this. I always thought this was an absolutely brilliant decision in the filming of Frankenstein, the novel, because it is obviously playing against these painterly depictions in the 19th century of an idyllic, sublime nature, and to locate the monster of technology in that idyllic setting of nature, I think it's absolutely brilliant. And as you know, the story does not have a happy ending, because Frankenstein's monster, out of innocence practically, ends up throwing the poor little girl into the lake to see if she would float too, like the flowers. And then, of course, all hell breaks loose and they chase down the monster and destroy it. So it's just a wonderfully vivid story of our anxiety about technology. And the setting for this anxiety concerning technology is nature, but a very particular image of nature. In our time, we have a version of the story of Frankenstein too. This is from the movie Gattaca. I don't know if all of you have seen that. But the idea is this future science fiction scenario where human beings become genetically altered. So you have beautiful, intelligent Uma Thurman here who has been genetically altered, and we have poor, hopelessly imperfect Ethan Hawke who was born naturally. And then the whole story kind of revolves around this relationship, which is, in retrospect, quite hilarious. But what interests me about the re-emergence of this Frankenstein mythology is, in contemporary times, it's less disturbing. And if anything, we celebrate the monster or celebrate the artifice, the artificial, and see the natural as problematic. We also see more and more projects like this. This is from an artist working out of the UK. And it comes in a book, I think called Next Nature. And all it is just Photoshop. This isn't real, of course. But the celebration of the possibility of a kind of artificial naturality, to use Benedetta's term, I think is just very strange that we seem to be growing a kind of ease with this prospect. And at the heart of it is perhaps an understanding of technology and our relationship to it. So there are questions about what is nature, what is technology, what is our relationship to even ourselves with our own bodies as a piece of nature, and then again to the outside. So this is, I think, eminently an architectural question, because architecture has always been at its highest a kind of proposition about the world. And so talking about technology, it's almost synonymous with computation and the computer now. And it's always good to remind ourselves what technology actually is, or the computer rather actually is. It is a patterning device. It is a set of dynamic switches for the purpose of patterning this stuff. And it took almost 1,000 years for the idea to actually be successfully mechanized. Upon research, you'll discover notions of the algorithm and computation and stored human memory through a machine, even in medieval periods. And so it is kind of remarkable to see almost a continuous 1,000-year-long tradition of speculations about how to then mechanize that idea, going through everything from famous difference engines, Leibniz, and all these things involving gears and so on and so forth. And ultimately it gets to this point. And I actually went to saw this monster, and it really is a monster. This is the first real successful version of the mechanization of computation. This is at the University of Pennsylvania, the ENIAC. And it's also good to remind ourselves why this thing was funded. It was because of the Manhattan Project. And meanwhile, there were dark basement rooms at the bottom of the War Department filled with women that were doing hand calculations for the Manhattan Project, and the idea would be that this massive machine would replace what were called the rooms that were filled with the computers. So it originally referred to these people, but specifically women. And then the name just got transferred to the machine, which is also very interesting. And one would think this is too abstract, but in the end, it was successful. So there is this strange, undeniable link between what computation is and what nature is, because in some sense it was an absolutely spectacular material success. Switching to the 19th century, we look at images such as that previous slide, and it's undeniable that there is a strange aesthetic content to it, which is difficult to accept as aesthetic content. And I started becoming very interested in how, as a pure aesthetic problem, what it most resembles is the sublime. So if you could compare, say, a painting in the 19th century where you have the human being overlooking the sublime, it is nature. The subject matter is nature, or the object of the interest is nature. It's something outside of human making. It's something outside of technology. It's mysterious. It's inaccessible. But yet, the strange thing about the aesthetic condition of the sublime in the 20th century is it switches around, because the object of the interest of the sublime is now the production of the human being. It is now a technological sublime. So in this sense, I started having what I thought was a productive way of understanding all the kind of somewhat geek material, nerdy material that was being multiplied in the time right after grad school. Right after I graduated in 96, 97, from Columbia during the famous paperless studio times, I was quite skeptical, intensely skeptical, even though I was really diving into the pool with full embrace. I tried to learn as much as I could, just completely uncritical. I thought it was more important to learn it than to judge it at that moment. But at the same time, internally, I was deeply skeptical that it shouldn't just be about the multiplication of tools, that just the acquisition of technology in and of itself had no value. So This interest in the sublime, in aesthetic questions regarding technology and our relationship to this, what was becoming for me a more and more vague word, nature. At this point, it almost ceases to have any meaning for me at all, and I'll talk about that more later. But you begin to see strange objects from computation like this. This is, I guess, it has a name. It's called the Mandal Bulb, which is a new form of hybrid fractal construction. And it comes out of a simple expression such as this. And people have actually done animations, like I guess fly-throughs of this construction, keeping in mind this entire thing is defined by essentially 10 lines of code. And this really is not a real object in, I guess, the architectural sense of the word, because this is really not about physicality. But nonetheless, it is an object of a kind. And the thing that really shocked me about this particular fractal, first of all, I completely separate this from what I would call architecture. I don't think there's anything architectural about this at all. But nonetheless, for me, it became a kind of object of consideration, because what was beginning to emerge out of abstract systems like this are things that started to resemble things that we would think belong to the architectural formal vocabulary. I'm waiting for one thing to pop up here to advance to the next slide. It's this thing emerging on the right-hand side. That just astonished me, where this fractal turns into what appears to be strange Baroque ornamentation, which really is completely accidental to some degree, because who would have known things like that would have come from that? In fact, it had nothing to do with this kind of work. But nonetheless, these things begin to emerge formally, and then it just starts to make you wonder, like, what is the relationship between this thing called computation, what we call the architectural formal domain, and nature, finally. So this is really kind of a summary of some of the work that we did in the first 10 years. Some of these are quite old, and I feel to some degree uncomfortable, like, reviewing it. It's, to my eyes, they look very dated, which is strange, condition of technology too. But throughout the various projects, our speculative projects, we were always trying to privilege a kind of, or foreground the aesthetic problem of computation and digital tools, and to look for things that were more relevant to the architectural discipline rather than talk about what kind of tools we were using. We were, even to this day, I'm extremely reluctant to talk about how we did this. After pretty much most lectures, in the various lectures I've been doing over 10 years, I was always depressed that the first questions were always about what kind of software do you use, which I find to be like an unimaginably retarded question. And, you know, because it really shouldn't have anything to do with that. If it is not relevant beyond the tool, it's just not relevant as an architectural disciplinary problem. So, I mean, if you are a technologist, I suppose it is important, but it just isn't that important to me. So, but nonetheless, we went through all kinds of things, and a lot of it quite esoteric. Our aesthetic interests moved us through a lot of technical territory. And again, my point is the motivation was never technical. We had to pursue certain techniques in order to arrive at certain conditions of aesthetic experience that we were hoping for. So there are moments where we're rethinking the architectural cross-section as some sort of collapsed, transparent model. We're looking at non-conventional ways of drawing, like, can you use a CFD software, computational fluid dynamics software, as a kind of etch-a-sketch, like as a way to sketch ideas instead of simulating ideas. And I don't think there's anything wrong with using these for technical or simulation purposes necessarily. It's just that it wasn't the right way for us to use it, we thought, because our interests were about something else. But studies like this, which were pretty technical, resulted in what I thought were some interesting results and possibilities for design that some of which we pursued, others just kind of died on the operating table. Some of them became known to my colleagues, others are still kind of hidden on the hard drive. This is just a rendering of our PS1 entry. And briefly, like just showing it, what I feel like is like the 1000th time in public. It was important to us to completely accept the technological possibilities, but to evaluate them differently. That it wasn't really about technology, but about, once again, the aesthetics. So for example here, I think a lot of people who know CFD software would think this is absolutely bizarre, that we would be using CFD software and meshing techniques associated with it for the purpose of producing a decorative pattern as a template for a giant macrame project, for example. So we enjoyed some of the kind of strangeness of the results, because that actually led us to think that we were actually on the right path, because the essential meaning of these projects always seemed to some degree withdrawn from our own kind of retroactive theories about what they were. The projects themselves always seemed to be more than what we could say about it, and I think that is a kind of a good sign. I think that was a clue that we should keep doing it. This incidentally was a very strange mathematical software, very obscure for calculating knots. Like mathematical topologists use this. So we basically used this to figure out how much rope we would need for that previous project and how much it would weigh and things of that sort. But it opened up a lot of doors for us intellectually, because there were very non-standard concepts of precision, which potentially seemed incredibly useful, later on. But again, this is the kind of period in our work where it was primarily concerned with aesthetics. And at this point, at this moment in time, we're actually very critical of what we were doing back then, because I think there is a kind of almost a hopeless nostalgia about nature that's kind of backgrounded in all of this technical work, that it was kind of driven by a desire to reproduce what we found to be beautiful aesthetic experiences in nature. But the moment we started questioning a little bit more deeply what nature is, all of this work started feeling very overly sentimental. So I'll also address that too shortly. Yeah. And there's some very interesting alternative possibilities that are kind of shoved in our file cabinet now that we'll probably pull out 5 years from now, where we were even thinking about just a completely alternative procedure for how to document a project so that it can be built, that it's not a scaling up a form and kind of piling on annotations to it for indemnifying oneself, but more a kind of music notation to so that a bunch of players can have something in common with, which signified that we would lose a lot of control, and we still struggle with exactly what that would mean to lose formal control, to gain kind of potentiality in how things are put together. Yeah, and there were extensions where we were speculating about, could something like that happen through complex prefabricated modules and so on and so forth. So a lot of questions that seem almost typical now, I think. I'm just coming from another digital themed conference at University of Houston, and a lot of these kinds of questions were being asked there too. And I think it's just fascinating that there is a kind of general interest in moving to another period in computer-based work. Some I've heard even use the term post-digital. Post-digital meaning, I suppose, that we're not completely invested in the digital per se, but how that acquires extended values, like questions concerning culture, nature, and of course, most importantly, meaning. And so where this is heading is I want to point to where things started taking a turn for us. So this is the kind of nostalgic project we were doing. I think I can forgive myself in retrospect because it seemed, even in retrospect, an interesting way to make these highly technological tools and techniques non-technological, to associate it with a kind of desire for metaphorical signification, like how do you make an aluminum waterfall? And so instead of focusing on what kind of laser cutter you used and so on and so forth, or what kind of algorithm laid out this installation, the interest was more in that question, like does this kind of capture the original interest in a photograph like that, but done out of aluminum through laser cut aluminum. And then it becomes very precise. So I would really distinguish it from a more phenomenological approach in a traditional sense, where it wasn't really about translating that phenomenal sensitivity to another form of tectonics, but rather it almost immediately goes into a kind of almost a deep, meaningless, impersonal level of geometric detail and form making. So it almost becomes a kind of impersonal agency as a designer, that there's really nothing to say about the form anymore. All you can do is work with the very specific constraints of the material or the tool and so on and so forth. How much is it going to weigh? And how do you connect it? And yeah, everything becomes super low level, and I think that's important because in some sense that's what we used to call craft, I think. Yeah, so more of this kind of sentimentality, like can you then do this unrolled cutting technique and marry it to kind of traditional notions of decorum and wallpaper, and can they be tiled? Can you make a three-dimensional wallpaper that could be in between furniture and wall and so on? Yeah, and it amazes me how much money we wasted like fabricating stuff. But it was important. I'm joking. Yeah, I think. Yeah, more of this kind of stuff. Like you look at it, and it's a kind of earnest interest, because we would look at like the skin of the iguana and it's like, my goodness, look at this thing. And like here we are talking about form versus function. I mean, look at that. I mean, it's neither really. There's an entirely another level of interrelationship within the object, which is almost beyond knowability. I mean, we did the best we can to figure out what's going on in systems like this, but really we've only scratched the surface, and perhaps it will always be to some degree withdrawn from rationality, I don't know. But it led to very specific things like, okay, instead of making a nice curved surface and figuring out the most efficient set of milling lines to reproduce that surface, maybe there's some other way to use the CNC machine. So we call up Ken Tracy and say, hey Ken, is there a way to modify the tooling paths themselves? And of course, like brilliant people like Ken Tracy come along and come up with like these incredible ideas to how to design the milling paths themselves. And I was completely energized by this kind of possibility of collaborating with fabricators on almost a kind of guild-like level where there's a kind of intimate conversation between the fabricator and the designer. Yeah, and there's some good lessons along the way, of course, like toxic fumes from the paint and things like that. And yeah, but anyway, so this is where things took a bit of a turn for us. During this process, I came across one of these two photographs that I showed you at the beginning. And I think it was kind of an indication of how crazy we were at the moment. We're just so in the project, where the first thing I thought when I saw this photograph was, oh, who did that project? That's kind of an interesting surface. I wonder how they made it. And then I started looking at, wait a minute, that looks like an old picture. And then I finally looked at the caption, and of course, it's not a project. This is a photograph of Evelyn McHale in 1941 who jumped from the Empire State Building and landed on the roof of a black limousine. And it's a strange, strange photograph. So it's at that moment where, and I stared at this obsessively over the next month. At that point, I couldn't deny that I was interested in the problem of the meaning of these things, that ultimately the kind of technical interest had somehow run its course. My attention was beginning to shift. But I think it is kind of a necessary thing in general, in retrospect, that it's only natural, I guess, to use a bad word, for these kinds of innovations eventually needing to come into contact with cultural problems. And when we say cultural problem, it means that its place in the world is incredibly or hopelessly complex, and there's no single way to speak about what its significance is. So here we started pulling out some old projects that previously we thought was garbage. It's like, oh, that's an anomaly. We can't show this, just not part of our work. All of a sudden, oh my goodness, it's that crazy thing we did 5 years ago is absolutely relevant to where we were going. So this was a collaboration we did with an artist. And the idea was to see if we could project a kind of strange mix of Moorish and European ornamentation into this kind of swirling cloud of projection. We never felt comfortable about showing it because it's kind of more of a media project, I thought. Some of this kind of embarrassment about not doing architecture, but then all of a sudden it became absolutely relevant that we were initially playing around with how could some of these pure geometries and these complex formal systems begin to have a relationship to a culture or side to regimes of meaning. And then this led to this project. And this was a very important project for us because this is where I think we really started to put things together, where it really bookended this kind of interest in technical experimentation. We were asked to make a piece for the show called Matters of Sensation. And I thought, okay, if the theme is sensation, maybe this is a good time to think about something completely different from form and geometry, software. We're going to think about the Rorschach Test. And the reason why was because we were interested in the problem of meaning and projection and signification. So I'll talk a little bit about what we think of the stuff, and it'll probably start becoming obvious why we became interested in it. If you wanted to design a test to discover what people had locked up in their heads, you would think the obvious thing to do is a blank screen, that you put a blank screen in front of them. And whatever they project from their mind, that's the best kind of test. But yet it's the opposite. It is a completely arbitrary set of intricate marks on paper that ends up becoming a test for the projection of emotionality, because the notion that it is meaningless is untenable. It is almost impossible not to see things in things like this. And that we found to be very interesting, because at the same time it gave us a way to contextualize this kind of fascination with computational intricacy that was all around us. So it gave us a way to think about like an early 2002 interest in computational intricacies relationship to Max Ernst, for example, who was essentially producing inkblot tests. If you know anything about how he made these things, there's this funny word called decalcomania, which is about pressing paint to produce these strange, it's like a miniature thermodynamics, like a sandwich between glass that then gets transferred to the paper. and then a process of reading these random marks and seeing like the head of a bird and things like that, and beginning to cultivate meaning out of something that essentially had no meaning. So this is what we started playing around with. So our fabrication projects turned into kind of studies. This is really not a project, but a study in this kind of problem, where we say, all right, what would it mean to, or how would we combine the emotionality that we would associate with a Ducati motorcycle, roses, and musculature? And then it led to the production of objects like this. So what we started becoming very interested in how was in the possibility of architecture being an object. This was also kind of a reaction against what we feel to be a kind of prevailing tendency since the mid-90s towards the field, away from the architectural object, towards notions of the architectural field. It seems almost natural to think of architecture as a kind of consequence or artifact of context, I think, today. And we find that to be really weird. As someone who loves architecture, I would like to reserve some part of architecture that has absolutely nothing to do with the field, that is somehow this dark nucleus that is purely architectural, that really is the resistance to context. And yeah, so, and this has led to like some of our recent work, where in even the design of a house, we're beginning to think about how do we design it in terms of privileging it as an object condition, but also to not worry so much about context. We would, of course, like do some very practical things with context, just make it work, but somehow its meaning is lodged more internally. So it led to this experiment where we it sounds almost funny actually, but we were making our own Rorschach tests. But what it was actually was to shift from a geometric mentality of design towards a more painterly mentality of design, where instead of dealing with simple primitives that would be building up computationally, the idea was to have complexity from the get-go. And it led to some ideas of how to produce dense mats of line work through techniques that we never really even thought was possible. And it led to some of these initial ideas for how to fabricate the object for the show. And I remember 3 years ago, like Robert and I, we were having fun conversations about the relationships between this kind of computational ornamentation with older traditions like Sullivan. And you look at even Sullivan's own theoretical speculations for how he was doing the ornament, which was, I'm convinced now, totally retroactive. And there's something intensely algorithmic and computational about how he's trying to explain the buildup of the geometry. It continues to be absolutely fascinating. Because to my eyes now, it actually looks like subdivision surfaces on this, to use a technical term, you know. Yeah, so some more of the image. And then, after having learned a thing or two about toolpaths from Ken, we started actively working more with the toolpaths ourselves. And we had to do it because every shop we took our geometry to basically said, get out of here, you maniac, that's impossible. It's like they never had seen, and this was like 3.5 years ago, and I don't think it's any longer a problem. I mean, even already things have improved quite a bit. But we were taking around this file consisting of approximately 3.5 million 1-degree patches, and they couldn't even open the file for the most part, So we had to kind of convert the file ourselves into the paths as sufficiently as possible, and then take the toolpaths to people. But it was kind of interesting to see it because it's, again, another aesthetic condition in and of itself, which I thought was fascinating. It's another kind of drawing. Yeah, and very naturally it led to almost a kind of surprising kind of relationships with previous projects like Frank Lloyd Wright's textile block houses. And it kind of fit in perfectly with the way we were thinking, because I was always struck by how something like the Ennis House had such a versatility, I guess you could say, in terms of what the forms meant, so that the Ennis House could be the setting for the year 2300 for Harrison Ford and Blade Runner, or the house on the haunted hill. I thought it was absolutely strange. And even in photograph today, just taking a photograph of it, it seems to be kind of vacillating in this kind of strange territory where its meaning is not entirely clear. And like the Rorschach Test, somehow whoever comes to it would have to bring their own regime of signs with it, because the thing itself is somehow vague, even though it's absolutely specific. So these are some of the objects we made in collaboration with this great company, EOS, that was an offshoot of BMW for printing not models, but final parts that theoretically would go directly into the car. It didn't turn out to work, really. It was too expensive and it wasn't strong enough. But the holy grail of manufacturing remains moldless manufacturing of parts. And it's spectacular, the materials that they can print in. It's I mean, if you look at this list, 3D printing in stainless steel and cobalt chrome and titanium. And those little objects they did for free because they were curious to see what we would do with it. And it was just wonderful to work with them. But their interest was essentially like, is there an architectural application of this which could allow them to sell more machines, which would make the parts cheaper, et cetera, et cetera. So their current applications are primarily in the medical industry. So if you have a bad accident, they'll 3D scan your cranium and print in stainless steel a replacement. And they, every year they seem to screw around trying to find another application, like having a fashion designer 3D print a purse, which looks like chainmail with brass knuckles on it for some reason. You know. But we're continuing to work with them, and right now we're just playing around where we're trying to 3D print in metal a kind of extrusion detail to hold glass for this house we're working on, and it's kind of I'm tentatively telling you about it because there's really no hope that we could do it for real because it would be so expensive. We might set the record for the most expensive window detail ever done. But it's, I think, important for us to keep thinking about where some of these things go, because in our practice at least, our experiments are essential to how we practice. So this is where I'm going to end. This is the latest thing. So as I mentioned, right now I'm trying to finish the book and we're trying to get our building projects going. But we can't say no to certain things. It's just impossible. So when we met these local synthetic biologists, and they're interesting in and of themselves. They're young researchers, young synthetic biologists that are frustrated by the research that they're not allowed to do because of the bureaucracy of the research university. They got together and opened a nonprofit laboratory, level 3 laboratory in Brooklyn. And it's hilarious. They refer to it as the local gym, you know, where you pay a membership. You don't have to even be trained as a biologist. They just need to take you through some safety protocols, and you could do biology projects, right? And so when I was just amazed that they were in Brooklyn, I just went over there to talk to them, and we started talking. And it was some far-out ideas. Like one of them was talking about an organic watch that they wanted to make, kind of a flesh watch, and because somehow the cells already keep time chemically, and so on and so forth. So then they showed me, I got to learn through them some of what's actually happening with 3D printing today in the medical industry. And this is, by now I had already grown fatigued with 3D printing and like not another 3D printing project, but you're 3D printing a kidney. Okay, that's, now you're talking. That is interesting. So when I started learning more about it, it strangely resembled some of the techniques we would already use. Like, for example, having this kind of balloon-like mold and then depositing kidney cells over it. I mean, it's like practically vacuum forming. It's strange, and it's just tissue culture. And they were explaining to me the kind of magnificence of the intelligence of the cell. It knows when it's closed up and reached a neighbor that is another cell, and it stops growing. And like these signaling events, and it was just incredible to learn about what they were working on. So this I just spoke of. I thought this is kind of the more architect's idea of what it would mean to intervene in the body. It's a problem of form, mass, structure, and aesthetics, obviously, is also important. But this other stuff seemed to be dealing with something else entirely. So we said, why not? Let's collaborate. I have an open invitation to this art gallery anyway, so yeah, why don't we do something with what you're doing? And I asked them to, okay, can you work up a spreadsheet for me so I could apply for a grant? And it's like, okay. So I'm anticipating like a spreadsheet coming back over like $100,000 or whatever, because we wanted to make our own bioprinter. And then this comes back. It's like, you've got to be joking. And they explained to me, well, all it is a modified inkjet printer from about 5 years ago. And well, why don't you, since it's so cheap, why don't you get a new one? and the answer was, oh, the new ones won't work. And the answer is because the technology keeps getting better, the resolution's increasing, the holes on the piezoelectric head are getting smaller and smaller and smaller. There was a brief window of time 5 years ago where the holes on the piezoelectric printing head were the perfect diameter for a living cell. And so we have to get the Hewlett-Packard Model 3000 inkjet printer on eBay somewhere for $70. Right? And yeah, so on our end, we know really nothing about this stuff. But we're more fascinated about how difficult it is for us to think about this stuff as architects. There's something about the architectural discipline that has a real blind spot with materials such as this. So we're kind of going through some simple ideas. We put these two slides together more to talk to the curator when they ask, so what are you going to do with this bioprinter? And because they don't want to display the bioprinter, they want to display what we do with it. So it's like, all right, well, maybe what we can do is the output of this printer, we could stain it, dye it with organic dyes, and see if we could produce some kind of painterly artificial flesh. And it's like, oh, a living painting. It's like, yeah, that's exactly what it is. But I have no idea if you can do something like this, because again, we're working with the prejudice of a stability in the result, and clearly it's not something that you can control. It does have a kind of life of its own, quite literally. So as we continue to work on this, we stumbled upon what's so significant about this final photo. This is a photo of Henrietta Lacks, and the synthetic biologists we're working with, they recommended we start with kind of standard bovine cartilage tissue, and there was like some sort of serial number for it. It's kind of standard cell culture. But there was this other type of cell culture that has a very strange story associated with it. The HeLa cell culture is more or less standard now in medical research. It really is global. It's used globally. We wouldn't have the polio vaccine, for example, without it. We wouldn't have AIDS research without it. We wouldn't have cancer research without it. And the source of the HeLa cell culture is Henrietta Lacks. And this wasn't discovered until recently. So HeLa, H-E-L-A, was an acronym for Henrietta Lacks, who passed away in 1951 with cervical cancer. The doctor at Johns Hopkins that had removed a part of her culture after Henrietta had passed away was astonished to discover that the cells were still alive. And this is something that has never been reproduced. They have never found another example of a living cell that was essentially immortal. And those cells from that small part of a tumor has been multiplied and cultured and manufactured and distributed. So Henrietta Lacks, in some sense of the word, is immortal and is as large as the planet, as she exists on a planetary scale. So how do you think about something like that? If we are going to use the HeLa cell culture and we're going to print it on a bioprinter, exactly what will be the relationship to our body of work to this point? So that's kind of where we are. And this is the first time I've actually shown this, but it seemed appropriate for your theme. So I'll probably end with that. Yeah. Okay.